Okay, so today I'm just going to make a short video to explain to you how to do the maths involved in titration questions where you're going to use the first principle methods. That means the method where you no longer use the Vm over n formula. Okay, so before I actually talk you through the maths, I just want to kind of explain to you how you can spot when you have to use the first principle method. So you will have to use this method when the question first asks you to find out the number of moles of the standardized solution first. So if we look at a few examples here. So this is 2019, the first question here. It is said that you're trying to find the dissolved oxygen. And if we read along, and we would have read through the whole thing, it says the concentration of free iodine was measured by titration with a standard solution of sodium thiosulfate. The first question says, find the average number of moles of sodium thiosulfate. So you can see you're finding the number of moles of the standard solution, so we're going to have to use this first principles. Okay, I'm now looking at 2018. And the total hardness was estimated by reacting with a standard solution of EDTA. Then the first maths question, the average number of moles of EDTA used in the titration. So again, it's the number of moles of the standard solution. So therefore I have to use first principles. Okay, 2017. If you have a look at 2017, a solution of blah, 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 blah was used as a primary standard. Go down to the maths. Find the number of moles of Fe2 plus in the standard solution. So again, number of moles in the standard solution. So that's your first principles. Okay, so this is the next question. So if we look at part C, it says the number of moles of sodium hydroxide used in each 25 centimeters cubed portion. So have a look at the question up here. So we are on 2016, and maybe pause this and have a think for yourself based on what you've just seen. Would you need to use first principles here? And again, it's a standardized solution of sodium hydroxide, and they're asking for the number of moles of sodium hydroxide. So again, standardized solution, number of moles in the titration. Yes, you would have to use first principles. This is 2015. Again, if you want to have it open in front of you and have a read through. Then go down to part D and the first part of the maths there. The number of moles of iodine in each 25 centimeters cubed portion. Have a think for yourself, is that first principles? So you can pause and have a think. And the answer is yeah, because if you look up here, it's a standard iodine solution. The number of moles of iodine. So again, you're using first principles there. Okay, and the last one we're going to look at, if you look at 2014 and have a read through, and we go down to our maths, which is part E, and it says find the moles per litre of the sodium carbonate. Have a think for yourself whether you have to use first principles here. Now, if you look up here, it says it was standardized hydrochloric acid. So when they're asking you for the moles per litre of sodium carbonate, it's not the moles of the standardized solution. So actually, in this question, you don't have to use first principles. So what we've basically seen there is first principles is used all over the place the last few years. So 2019, 18, 17, 16 and 15 all had to use first principles. 2014 didn't. So we're going to actually talk through how to do that now. In doing these calculations, you should at this stage be really, really familiar with your star here. So changing from volumes of a gas, which we won't really need for these calculations, but I'm just putting it in so that we have the same star, number of particles and grams, all back into moles. You should know this off. Okay, so I'm going to use 2017 as our example of how to kind of go about this, but it's the same steps basically for each year. Okay, so we're on 2017 and we're trying to find the number of moles of the standardized solution in the titration. So if we look at the 2017 question, It asks for the number of moles of iron in the 25 centimeter cubed portion that was used in the titration. So if we read through, what we've been told is we have the grams in the flask. So you could have been told the grams per litre, you could have been told the moles per litre, or in this case, the grams in the flask. So we've been told that we have 8.82 grams in a 250 centimetre cubed flask. So we are trying to find the moles in 25 centimetres cubed. So first steps first, always go from grams, bring everything back to moles straight away. So we know to go from grams to moles, you divide by the relative molecular mass. So in this case, for 2017, you're dividing by all of this. So 8.82 divided by the relative molecular mass, which when you do it out and you should show your addition, is 392. That will tell you that you have... Okay, apologies now, I've actually moved over here because there wasn't enough room on the page. So I've 8.82 grams in the 250 centimetres cubed flask. To change from grams to moles, I'm dividing by the relative molecular mass. So I'm going to divide this by 392. This will tell me the moles in the 250 centimetre cubed flask. So once I do that, I get 0.0225. Now I have the moles in the 250 centimetres cubed flask. I now find the moles in 1 centimetre cubed, so I divide by 250. Okay, so I'm dividing by 250 here. This tells me the moles in 1 centimetre cubed. Now to find it in 25, I multiply by 25. You're getting 2.25 by 10 to the minus 3. Okay, so again, just talking through what you do. You have the grams per flask, divide it by the relative molecular mass to get the moles per flask, then find the moles per centimetre cubed, then find the moles per titration figure. If I was given the grams per litre, that's the grams per 1,000 centimetres cubed, I find the moles per 1,000 centimetres cubed. Again, doing it the same way, grams divided by relative molecular mass. I then find the moles per 1 centimetre cubed by dividing both sides by 1,000. So you divide this number by 1,000. And then I find the moles per centimetres cubed of the titration. So whatever number I have here, I multiply it by however much centimetres cubed were used in the titration. If I was given the moles per litre, I just have to start from this step here. Moles per litre to moles per centimetre cubed to moles per centimetre cubed used in the titration. Right, for step 2, you're finding the number of moles of the unknown concentration used in the titration. You do this by using the balanced equation. So if we look at part 2 of 2017, that's what they're actually asking for. So in part 1, you found the number of moles of iron. So we found the number of moles here, and we found out that it was 2.25 by 10 to the minus 3. The ratio of these is 1:5. If I have 1 of these, I have 5 of these. So to get from this number to this number, 5 to 1, I divide by 5. So if I have 2.25 by 10 to the minus 3, I divide that by 5 to find out the number of moles of this that will react. 1:5, 2.25 by 10 to the minus 3. So this will be 5 times less. 2.25 by 10 to the minus 3. And that will tell you the number of moles of this that reacted. So that's your answer for 2017. And then lastly, this is the number of moles that reacted in the titration. You're trying to find the concentration, which is the moles per litre. So if you read through the question, somewhere here they would have told you how many centimetres cubed of the unknown solution was used in the titration. So you'll find it here in 2017. On average, this many centimeters cubed was used. So this many centimeters cubed contained this many moles. So again, this many moles is equal to this many centimeters cubed, the titration figure. Find out how many moles there would be in 1 centimeter cubed. So we divided this by that number. So it will be this number divided by 20.45. Will tell me the number of moles in 1 centimeter cubed. And then multiply it by 1,000 to find out the number of moles in a litre, which is your molarity, the concentration. Okay, so that's the calculations done there. So this is your moles per litre, or your molarity. And that's the main parts. So there's obviously additional parts that you might have to do. Like you might have to change from moles per litre to grams per litre. Again, use your star to do that. Going from moles to grams, multiply by the relative molecular mass. You might have to find the parts per million. That's the milligrams per litre. So once you found grams per litre, multiply it by 1,000. Or you might have to find maybe the percentage weight per volume. That's the grams per 100 centimetre cubed. So if you found the grams per litre, just divide it by 10. So they're all additional parts that you might have to do. But up to step 3 is your first principles. Okay, hope this helps. And you know the questions that it comes up in. So feel free to practice them and then let me know if you're getting stuck on any parts.